Have you ever looked at a world map and thought, hey, those continents look like they fit together? Well, for centuries, people saw it as just a static jigsaw puzzle. But what if I told you it's not a puzzle at all, but a snapshot of a planet in super slow motion? Today, we are diving into one of the greatest scientific detective stories ever told, the hunt for the incredible engine that actually moves entire continents. So check this out. The first clues were, well, massive. Scientists started finding fossils of the exact same land-based reptiles and ancient plants on continents that are now thousands of miles apart, separated by huge oceans. I mean, how could a little lizard swim across the entire Atlantic? It couldn't. Then you've got the coastlines of South America and Africa, which fit together almost perfectly. The evidence was just staring everyone in the face. The continents had to have moved. But that led to this single, massive question that completely stumped geologists for like half a century. What kind of force, what colossal engine could possibly be powerful enough to literally shove a continent across the face of the Earth? For the longest time, nobody had a good answer. It just seemed impossible. And that was the Great Drifting Puzzle. The idea was brilliant, but the mechanics, they seemed to defy physics. So where did the first real clue to solving this whole thing come from? Well, the first hint of an answer actually comes from something you see every single day. You know, when you boil a pot of water, convection. The theory was that the incredible heat from the Earth's core could be creating these gigantic, slow-moving currents in the mantle. That's the thick layer of moltenish rock right below the crust we live on. And this is where a geologist named Arthur Holmes enters the picture. Way back in 1928, he proposed this exact idea. You're looking at his original drawing right now. He imagined these huge, churning loops of rock in the mantle that could literally grab the continents from underneath and just drag them along for the ride. It was an absolutely visionary idea, right? But it was also completely unprovable back then. I mean, nobody could see into the mantle. So Holmes's theory was mostly just set aside, kind of filed away as a clever guess. The real proof, the smoking gun for this planetary engine, was actually waiting to be discovered in the last unexplored frontier on Earth, the deep ocean floor. And that brings us to the next chapter of our story. See, after World War II, new tech like sonar finally let us map the seabed for the first time. And let me tell you, what we found down there changed everything. For the longest time, pretty much everyone just assumed the bottom of the ocean was this vast, flat, boring expanse of ancient mud. Oh, how wrong they were. It was a spectacular, dramatic landscape, maybe even more so than anything on land. There were these massive volcanoes, colossal mountain ranges, and trenches so deep you could hide Mount Everest inside them and still have room to spare. And snaking its way right through the middle of all this, running down the center of the Atlantic and all across the globe, was the biggest single geological feature on the entire planet. A continuous chain of underwater mountains we now call the mid-oceanic ridges. This was the clue that was about to crack the whole case wide open. So, with this new map of the ocean floor, scientists started analyzing the rocks themselves, and the data they got back was so shocking it just forced a complete and total rethink of how our planet actually works. The first bombshell was the age of the ocean floor. Geologists drilled samples from all over the world's oceans, and the oldest rock they could find was only about 200 million years old. That's it. Now, to put that into perspective for you, continents have rocks that are over 3 billion years old. The Earth itself is 4.5 billion years old. So, why was the entire ocean floor a geological baby? I mean, seriously, where did all the old ocean floor go? And the clues just kept piling up, one after another. First, the layer of mud and sediment on the ocean floor, way too thin. Where was the buildup from billions of years? Second, the rocks on either side of those mid-ocean ridges, they were perfect mirror images of each other in both age and what they were made of. And finally, and this is the kicker, the youngest rocks were always found right at the very center of the ridges, and they got progressively older the further you moved away. All of this pointed to one totally radical conclusion. This is the moment right here where it all clicks into place. All those clues from the map and all those clues from the rocks suddenly made perfect sense because of one elegant, powerful idea. So in 1961, a geologist named Harry Hess looked at all this evidence and put it all together. He came up with the theory of seafloor spreading. He realized that the ocean floor wasn't some static, ancient basin. It was a dynamic, moving surface. Okay, think of it like a giant conveyor belt. At those mid-ocean ridges, magma from the mantle is constantly bubbling up, erupting, cooling, and forming brand new seafloor. This new rock literally pushes the older rock outwards, away from the ridge on both sides. And then, finally, at the deep ocean trenches near the continents, that old, cold, dense oceanic crust sinks back down into the mantle, where it gets consumed and recycled. It's a perfect system. So you can really think of the ridge as a factory, just constantly churning out new crust. This explains why the youngest rocks are at the center, why they're mirrored on each side, and critically, it explains why the entire ocean floor is so young. It's not ancient, it's constantly being reborn and recycled. And when they did the math, scientists figured out this process is happening at a rate of about 2 centimeters per year. Yeah, that's about as fast as your fingernails grow. It sounds incredibly slow, right? But over 200 million years, that is more than enough speed to push South America and Africa all the way to where they are today. So just like that, the mystery of the moving continents was solved. But the solution was actually way bigger than the original problem. It didn't just explain one thing, it explained almost everything about the geology of our world. And here's how it all fits into the big picture. Seafloor spreading was the missing piece, the engine for the grand unifying theory of plate tectonics. This is the idea that the Earth's rigid outer layer is broken into these huge plates that float on a hotter, softer layer below. And those convection currents that Arthur Holmes dreamed up decades earlier, they were real, and they were the ones driving this whole seafloor conveyor belt. This is the engine that causes earthquakes, creates volcanoes, and builds entire mountain ranges. So the final answer was just so much more elegant than anyone had ever imagined. The continents aren't just plowing through the oceans like some kind of ship. No, they're just passengers, riding passively on the backs of these immense tectonic plates, which are being moved by the great conveyor belt of the seafloor, all powered by that incredible heat engine deep inside the Earth. The entire surface of our world is in constant, silent motion. The puzzle of the past is solved, but it leaves us with this incredible question about the future. That same engine is running right now, this very second, beneath our feet. So it makes you wonder, where on this planet are we all heading next?